Hello and welcome to this new module on TensorFlow and Keras. In this, we are going to explore about what is TensorFlow, what is Keras, and how it is helping us to solve complex mathematical formulas and problems. How we are implementing this to build up machine learning and deep learning models, and how it can be helping us to process the data faster and in convenient way. So let's try to understand the TensorFlow. So the objective of this module is to make you understand about different concepts in TensorFlow and Keras. So we will try to understand what is a tensor and what is TensorFlow. We'll understand TensorFlow in real-time applications, advantage of TensorFlow, how to install TensorFlow, TensorFlow 1.x versus TensorFlow 2.x, and the latest version of TensorFlow, eager execution in TensorFlow 2.x. Also, we will try to understand what is Keras, in which we will understand what is a Keras, advantages of using Keras, how to install Keras, why Keras, pre-processing methods, what are layers in Keras, and different models of Keras. At the end, we will also understand what is CNN and CV or computer vision, and also understand what is RNN and natural language processing. So let us begin. TensorFlow. TensorFlow is a combination of two words, that is tensor and flow, which is helping us out to process the data efficiently. And when we talk about data, the data can be anything, video, audio, or any information. So let's try to understand TensorFlow in detail. Before that, let us understand what are different level of ways in which you can arrange the data. So the first way in which you can arrange the data is scalar form or unit form. Scalar is a data which has no dimensions, which means it is unidimensional or no dimensional. Scalar is a singular unit of data. Basically, it will have only one value. Okay. Then we have vectors. Vectors are data with n-dimensional information. For example, it will have a series of information, list of names, list of students, list of numbers, and on and so on. So anything which comes in a form of list is called a vector. When we have data in the form of rows and columns, we call it as a matrix. Matrix is a combination of rows and columns. So we can see when the data in the form of matrix, in the form of table, can be considered as a matrix form of data. Now tensor. Tensor is a data which is usually in 3 dimension or more dimension. So data, when it crosses more than 2 dimension, okay, or it is 3 dimension or more than 3 dimension, we call it as a tensor. We can clearly see from the pictures as well, one-dimensional data or scalar is no dimensional, which means it is a scalar unit or single box. Vector is a list of box or sequence of data or a series of data. Matrix is a tabular representation of data, and tensor is kind of a grid structure with it is kind of a cubical form of representation of data. So tensors are data which are more than 2 dimensions. If you want to represent tensors in a different form, we can represent it like all this data in a different form. Scalar can be represented as a single unit value, that is 1, 2, 22, 23, any value. If you talk it, if it is singular, that is scalar. Vector is represented, as we can see, as a series of values. It has two values in a single series. In matrix, it is not a series, it is a tabular structure with two form of data, that is rows as well as columns. And tensor, as we can see, it is showing data as rows and columns, and within that each column you have multiple values as well, which means it is not 2 dimensional, it is more than 2 dimensional. Now we will understand TensorFlow. So what is TensorFlow? TensorFlow is a free and open source library, software library, which helps us to work on tensors of data. It is usually used in deep learning, and as deep learning is a mechanism where we want to analyze the data or the complex combinations of data, that is why TensorFlow is the best possible solution for it. So In deep learning, we are analyzing complex data which is in the form of image, audio, and it is not necessary that all the time the data which we are getting is always going to be in two dimension or matrix form. It can be more than two dimension. Images, as we know that images are three dimensional. Images are usually rows and columns, and a third dimension basically represents the number of channels, which means red, green, blue combinations of channels. So such kind of data can be easily handled using TensorFlow, and it cannot be handled with anything else. Like only in TensorFlow can help you out to handle such kind of data. TensorFlow was built by Google and released in 2015, and post that we can see there is a constant improvement in the field of deep learning. TensorFlow is to neural network and deep learning what scikit-learn is actually to machine learning. So it is like the heart of deep learning. Without TensorFlow, deep learning is kind of very difficult to handle. Like it cannot be imagined also. The way in which scikit-learn is there to machine learning. TensorFlow is very high demand and one of the most popular choices for deep learning. Like it is the only choice I would say for deep learning. Now, what exactly this TensorFlow is utilizing? TensorFlow utilizes CPU, GPU, and TPU, all three components of a computer. So it is used for computing. Like TensorFlow involves multiple dimension of data. Therefore, it requires all three processes by which it can process the data, all three processing units to process the data. Now we'll try to understand the real-time applications of TensorFlow. So TensorFlow in real-time application can be used for speech recognition. Speech basically speech basically is a combination of voice, tone, pitch, frequency, and everything. And all these combinations are not just one dimensional, it has multiple layers of combination as well. So it is more than one dimension. And to analyze such kind of data, which is a combination of multiple dimension, we require a complex architecture of database to handle it, which can be done with the help of Tensor or TensorFlow. Speech recognition helps us to identify speech of an individual. Then we have image recognition. Image recognition helps us to like when we are trying to recognize what is there in an image. There also we need to have a complex data and understanding. Data usually in an image is in a form of row and columns, and there is also if the image is colored, it is always in red, green, and blue. That's why the image is actually splitted into three dimensions, and that's why it is necessary to analyze such images with the help of TensorFlow. So only TensorFlow can help us out to store and process such information which is in the form of multiple dimensions. Then we have object tagging videos. So there are instances or there are applications where we have videos on which we have to tag. There are videos on which we have to tag people or tag objects. So that also can be done with the help of TensorFlow, because videos are a combination of multiple images together. Then self-driving car. In self-driving car also we require TensorFlow to handle such data. The data which is coming to a self-driving car is not just images, it is also sensor information from IoT devices which are attached to that self-driving car. Then we have sentiment analysis. In sentiment analysis also TensorFlow can be helpful to process complex sentiments in different forms or different layers. Mobile image and video processing. So when we are processing data using mobiles, there also we can use TensorFlow to process complex images, videos, and audios. When we are developing application for drones, so air drones, land and sea drones, basically they keep on capturing images from the land and surrounding, and these images needs to be identified and analyzed, and this can be done with the help of TensorFlow, as TensorFlow recognizes information in an efficient way. It is also used on on-device computer vision for OCR. OCR basically helps us to reading the documents on a computer images. So if there is a document and if you want to read the information or the text written on the document, we can do it with the help of OCR, computer vision. And when we talk about computer vision, the data which is kept on the computer vision application is also in a form of images, and we need to analyze these complex images. That's why we will require OCR. Smart reply, if you are constructing an chatbot or chatbot kind of application, there also the information which is stored in a chatbot is actually in a form of tensors of data. It is also using massively multitask networks for drug discovery. So if there is a complex architecture where we want to understand drug discovery or medicine analysis, biological mutation, anything like that, where the data is complex in nature, we can use TensorFlow there. Now let's try to understand several advantages of using TensorFlow. TensorFlow is very much efficient as it is flexible. It is flexible enough. It provides multiple models or multiple versions of the same model, and which can be helped which can be worked out simultaneously. So it is flexible across different models and different versions. Portability, you can work on any platform. You can work on any platform and device using TensorFlow, so it is portable enough for working on any devices. Research and production, so it is open for researchers to contribute, like anybody can freely use it. It is open for researchers. Auto differentiation, so it can manage derivatives computing. It can manage derivative computing process automatically, resulting a graph that can be visualized. So it can help us differentiate complex processes and get a graph out of it. Performance, it is helping us to allow to make performance. It allows you to make the most of your available hardware with its advanced support for threads, asynchronous and complex computation. It provides flexibility when it comes to processing the information and distribution of resources across your hardware. So it is that much efficient if you want to develop work on it. So these are certain advantages like flexibility, portability, research and production. It is used in there, auto differentiation and performance analysis. Now we will try to understand how to install it on TensorFlow on your devices. So if you are a Mac user, what we have to do is you have to open your Mac and open your terminal over your Mac, and there you have to type pip install TensorFlow. If you write pip install TensorFlow, it will install the latest version of the TensorFlow. If you do not want the latest version, you can use pip install TensorFlow equal to the name of the version or the number of the version. So with this you can easily install um, with this you can easily install it on terminal or Mac. Similarly, you can do it for Linux. You can write the code on Linux as well. Like you can open your terminal on Linux and you can type sudo apt get TensorFlow, or you can simply use your pip command, because nowadays the pip command is also applicable over Linux or Ubuntu. You can use on Windows as well. In Windows also you can use the command prompt or terminal, and you can simply type out pip install terminal pip install TensorFlow, or you can use your conda prompt, or wherever, if your Python is there, you can there also install uh, pip install Windows, pip install TensorFlow. With this command you can simply install your TensorFlow in your devices. Now we will try to understand the difference between TensorFlow 1.x versus TensorFlow 2.x. So um, initially, when TensorFlow was developed, writing a code in TensorFlow 1 was quite difficult and overwhelming. You need to be very much skilled in coding in order to write it. This gave rise to a high-level packages like PyTorch and Keras. Like, there were other developers who started investigating and working out like PyTorch and Keras. Keras is an interesting choice here, as in 2017 it was integrated with TensorFlow, and Keras is treated as an interface of TensorFlow. Basically, in order to make it flexible to write code, so Keras was kind of introduced in 2017, and due to the difficulty in writing code in TensorFlow 1.x, TensorFlow started losing out to other popular high-level programming libraries like PyTorch, Keras, and all. To fix this, they have the Google team in 2019 have integrated or introduced TensorFlow 2, and the syntax of TensorFlow 2 is kind of borrowed from Keras, and it is done in a way that it can be said that TensorFlow 2 is actually Keras, and you will interact with TensorFlow in a very efficient way through Keras. So they have integrated Keras along with TensorFlow, and Google acquired it, and it made it more and more flexible and easy to handle. Eager execution. TensorFlow 2 uses something called as eager execution. Now, this is a mode of kind of executing code, or DSA or DS algo. Eager execution simply means allowing Pythonic way of coding. This means allowing Python rules rather than using complex computational graphs. So here in eager execution, it is using the programming base Python's base executional method. Eager execution is an imperative, and is an imperative defined by a run interface where operations are executed immediately as they are called from Python. This makes it easier to get started with TensorFlow and can make research and development more intuitive. So it is very much efficient as it uses the Pythonic way of execution of code, and where like operations are executed immediately as we are like implementing in the Python. We do not have separate interface like compiler, interpreter, and all. So it is very much easier to implement. Writing a code in TensorFlow is very much easy. Also, like suppose you want to create a variable in TensorFlow, you can simply create it by using tf.variables, and you can pass in the value. It will create that variable. Similarly, you can add the variables as well. Like if you want to add the two TensorFlow variable x and y, you can simply use tf.add x comma y. Now see, it is not in usual normal variable that we are talking about. It is a TensorFlow variable, so it will be in a form of tensor. That's why it is better to use TensorFlow libraries to handle it out. You can use the print command to use it, and you can see the shape and size and everything is given over here. Um, Now, if you want to initialize a session variable by process, you can simply use like if you're directly printing add, so it will be difficult. But if you want to initialize, so what you have to do is you have to start the session as s. You have to run the session of TensorFlow s.run by using s.run. In the with command, you can use tf.session, which will activate the session as s, and s.run. In the session, you will be running tf.global variables initializer, and this global variable initializer will initialize the variable, and z will be equal to s.run of z, which will run the value of z. Now the value of z will be assigned with all the value which is there. Directly if we printed, we didn't get anything, but now if you print z, it will just give you the value 8, because it has now implemented and run on the TensorFlow. Initially it was not giving any value because it was considering it as a tensor, but after running tf.global variance initializer, it will create a global variance variables z. So z will now become a global variable and it will be executed. So in TensorFlow eager execution, into TensorFlow 2.1, TensorFlow 2, we saw this the problem, like a simple variable had to be initialized, and all these things were done in the previous version. So it was difficult to kind of run all these things in TensorFlow 1. So TensorFlow 2 made it very easy. They skipped the process of creating initialization of global variables. They directly, if you just run tf.add x comma y, and it will simply add the tensor values x comma y, and it will give you a tensor value with 8 and shape as none. So This makes it much more convenient to use and handle the data. Now we can also use TensorFlow too for working on data, because TensorFlow is the best way of handling the multidimensional data, and in deep learning neural network we will have multidimensional data all the time. So for that we first initialize the TensorFlow sequential library from the TensorFlow. Keras sequential is something that will help you to build up a stack of variables or stack of hidden layers on it. So we can add multiple layers, like we can add dense layer, again dense layer, a lot of different dense layer which are hidden layer we can add on our existing sequential layer. We can also add a layer of optimizer and the output layer and compile the output. So basically in deep learning also TensorFlow is utilized to create variables or create hidden layers. It helps us to create layers and deep learning neural networks.